Everybody. And please do get your questions in. We do have a lot of moderators here, and we do like answering them. So get them in. We'll also have some time at the end where we can, we'll walk through some of those questions so that everybody gets the benefit of the response. So today we're going to focus around the business use cases of Rekognition. We'll start with a little bit of a baseline on what the service provides, the core capabilities, and then we'll jump into how people are using it. So we should take this about 30 minutes, and then we'll have hopefully 10 minutes for Q&A. So if we think of Rekognition as part of the stack within Amazon Web Services, it's in the Amazon AI group. These are services where the AI is embedded. They're intelligent services powered by deep learning, which means the AI, the deep learning, the machine learning, all that stuff is done for you by the teams. And these services are provided as managed APIs. What that means is you don't necessarily have to be a deep learning expert in order to use the services. You can be, of course, and you can do a lot with that if you are. But these services are really designed to be as easy to use as an API call embedded in an application. So Rekognition's core capability is really around extracting rich metadata from visual content. That visual content could be frames in a video, could be still images, and these come as input to the service, either in real time or batch. And we'll talk a little bit about how you could do both of those using Lambda for real time, using AWS batch for large image analysis. Object and scene detection, facial detection and analysis, these are core capabilities of the service, as well as the ability to compare faces or search for faces, where we start to get into more of the security verification use cases. What's new in the service, we announced fairly recently, is image moderation, which basically gives you the ability to intercept images that are submitted generally by the public and identify inappropriate content before they get to being published on your website, which is obviously a great thing for protecting your brand and reputation. So when we think of object and scene detection, it's a case of looking at an image, understanding what's in the image. So we have Rekognition is trained with thousands and thousands of labels. We call them labels, and the API is called DetectLabels. And what you'll see when you submit a new image to Rekognition, and you can do this through the console, you'll see the labels that are generated as a result of all that training. So in this case, you can see the boat, plant, harbor, waterfront. These are examples of labels that are detected, objects that are detected within this image, and then you can see the associated confidence score. We also include things like architecture, concepts, urban, objects and scenes as well, like neighborhood. And so these are higher concepts as well as specific objects in the image. Facial analysis gives you the ability to understand what are the general attributes of a face, include the kind of the basic things that you can see in the image. Are the eyes open? Is the mouth, is the person smiling? Are they wearing glasses or sunglasses? But then we take this further and look into demographic detail, like gender and age range. We look into sentiment, capture the emotion expressed on the face, in this case, happy. We also provide landmarks, so the ability to understand exactly in the image where different parts of the face are, which is great if you're doing any editing or pixelation. It's great if you're doing cropping, so you don't crop through the face by just knowing where the face is. You see the bounding box there. And also, you won't put an advertisement over the face if the face is part of an online advertising image. The interesting use cases here, the deeper ones, are really about demographic and sentiment analysis, where our customers are taking images as input, possibly through cameras set up in stores, so that what that enables them to do is then identify the demographic, the profile of their customers as they're walking through those stores. And when cameras are set up behind a service desk, the same sort of thing, the ability to understand if the service experience on the customer, as expressed by their face, is a good one. Face verification is the ability to start comparing faces. Given two input faces, this similarity is produced. And what this is the beginning of is a Rekognition style use case. In this case, verification is important because it's a differentiation from an identification use case, because we're saying we have one photo of someone, we have another photo that's come in, are they the same person? So that works around knowing that one of those images, who that is, and then verifying that or validating that against the new image that's coming in. If we take that a step further, we get into the area of facial recognition, which is the ability now to recognize one face in a group of faces that we have pre-built. And this group, we call it a collection, could be something like employees, it could be a whitelist of VIP customers, it could be a blacklist of known problem fraudsters and people like that, people to look out for. Obviously, in a security use case, that's a powerful one. So what we do in that case, we're indexing faces into the collection, building that collection in advance. And when we index these faces, what we're storing is in the collection that you control is the metadata about the face, which is, we think of that as a feature vector. So it's a series of mathematical representations of the features of the face, the combination of which is used to match new faces, as you see here, the input face, with those in the collection. And when you get a close match, we produce a similarity score, a high similarity score, which will enable you to say that is the same person. New, I mentioned earlier, is image moderation. And this is great it gives you the ability to identify explicit or suggestive adult content in images. But where this is having a lot of impact immediately is in the ability to automate and optimize the manual review processes that already exist. Because obviously the risk of having inappropriate content published onto a website is very high for brand. It can hurt brands very much, and so reputation is a very important factor here. And so the ability to immediately offer an approach that helps automate that, even if it just reduces 10% by setting very, very kind of conservative levels on confidence, and that 10% then just takes the burden off the human curators. And going forward, you iterate on that and how the levels adjust as you get more comfortable with the sort of content. You can relax them a little bit and still maintain your posture. And you can see here we're producing a hierarchical taxonomy. What that does is enable you to you see the confidence score at both the top level and the second level, and that gives you fine-grained detail into saying a different type of, let's say, suggestive content would be appropriate as opposed to some other type. So in this case, female swimwear might be okay in some parts of the world, but not in others. Therefore, we would simply just give them a different threshold as produced by the confidence score. So here we see in this image 83.5%. That might be, it might be too high or too low for some cultures, and so we can move that around appropriately. So that fine-grained control is a key attribute of the image moderation feature. When we look at the APIs, there are certain aspects which are common across a lot of them, and so we've drawn out some of the key words here from the inputs. In other words, these are things that go into requests to different APIs. And so it's important, really, we call them out because it helps people level set on the sort of calls they can make and the sort of flexibility they have with the APIs. So the image can be expressed as either an image byte, in other words, attach it to the request. So this means you can be completely decoupled from AWS in general and just push this image through the wire in your request and have the response come back to you. So it's a stateless call from our perspective, and that the image comes in associated with the request, and then the JSON comes back. We see a lot of usage from using image as an S3 source. So a lot of people have their files stored in S3, and that's also a great reference point. Min confidence is the ability to say, is to set that threshold on, what are the labels I want to see above this level. Different attributes around the facial attributes really specifies whether to return the default or all attributes. Now, this is associated with the index faces API. With the index faces call, that's what's taking the faces in an image and putting that into a collection. However, you may also want to extract and capture the attributes, the sentiment, the gender, the age range, and things like that from that face. And so we've given you the ability to turn that flag on in the index faces call, and that's what we're talking about there with the attributes flag. The similarity threshold is the ability when we get into compare faces and face matching is the minimum cutoff. In other words, we need to see faces only at a 95% or higher confidence similarity for us to consider those faces. And a face ID is created when a face is indexed into a collection. A unique face ID is generated. It's effectively a GUID. It is a GUID. It's a hash of many things, but including account number, collection ID, face, and image, which gives you a very unique signature there for that face. So here are some examples. In a request to detect labels, you can see there we're calling the S3 object as the image source, and we're setting max labels there. We could set max labels to 10, let's say, min confidence to say 70%. The default from the API is 50% on the min confidence, and there's no max labels limit. So you can set that so you can reduce your output from this call to a much higher quality. In terms of outputs, here are some interesting outputs across the APIs. Labels themselves is an output that expressed in the API response where an array of labels is detected. So this is what will describe the label array there. Face details is where the facial attributes are responded to from the call to detect faces, where things like the gender, the age, whether they're smiling, happy, and so on, will be returned within the face details array. Confidence is a level of accuracy confidence for labels. In faces, it also returns a level of accuracy of the face detection. In other words, we are this confident that we've detected a face. In some cases, we have obscured faces, oblique turned faces. It's harder to see that, so that confidence level will drop. Similarity is simply the score that is applied when we have a matching situation, either through comparing faces together or through doing a face search against a collection. And orientation correction is an example where an input image comes in at a different orientation, and so we will correct that and report that back to you. So you can see here in the DetectLabels example, this is the response that would come back from a call to that, where you would see the confidence and the name under the you see the labels attribute there. The confidence and the name are those which, in descending order, you'll see the confidence and the name being the label name. The orientation correction referring to at the image level. So this can be applied in a number of ways. If we think of batch processing, and AWS Batch is a great, fairly recent service. And there's a great blog article on how to process millions or billions of images through Rekognition using that service. What that will provide you is essentially, you can imagine you just build a list and then submit it, and yes, that's essentially it. However, when you have a lot of images, you need to preserve the state. In other words, have a queue that preserves the state when you go, how you're processing through that list. And AWS Batch will do that. It'll build its own queue there and preserve that so that those calls are made and you won't be doing the same image over and over. You have restartability and all the good stuff associated with high-scale processing. With Lambda, we have, and this is more for that real-time processing, the ability to upload a picture, an image into, say, S3, and have Lambda automatically take that and run that through a Rekognition API call. That could be pushing faces into a collection, it could be returning the attributes of the face, or the labels of the image that's input. It could be doing all three as well. So with Lambda, we've provided blueprints here. We have, you can see detect image labels as a blueprint within Lambda itself. So very easy to find that, and then the code is embedded there, including the ability to push that out, not just to the standard out to the console, back to the application, but into a DynamoDB table. Elasticsearch is a very popular integration we've seen from customers for obvious reasons. By outputting the Rekognition response details into Elasticsearch, one, you get the confidence level associated with something, but two, you get the attributes. Elasticsearch is able to apply a weighting factor to that, which obviously increases the search probability of high confidence things. And so we've seen a lot of these integrations going forth. You can see there with a Lambda function there called add photo Lambda, pushing that directly into Elasticsearch after picking it up from the bucket, running it through Rekognition, and then outputting it into the search cluster. So what can you do with Rekognition? We look at some of the scenarios that people are using. We have many customers adopting. And so we tried to normalize these across a number of different general approaches. So search is a very popular general pattern I should have said general pattern. Search is a very popular pattern that we see for people looking at object scenes, looking for specific people in a recognition, a facial recognition environment. It could be building an index and then searching against that to find things like images of houses with pools in it, or cars with different types of cars, something like that. The APIs here where search is used predominantly DetectLabels, search faces by image, and search faces. So this is where DetectLabels will, in the example you can see there, take an image as input, convert that by Lambda into an Elasticsearch index array, and then fuel that property search against that. And that's generic. It doesn't have to be property. It could be anything. It's a very powerful combination. Search faces by image and search faces are ways of finding faces in a collection, the same sort of thing. And a good example of search was done by the Washington County Sheriff, who was able to index 300,000 images of previous offenders, and they got that all done in a couple of days. It's a very fast process, especially if you know and if you want to preserve the name of the person in the image. If that's associated with that, then you can build your own index and do an identification scenario very quickly by running through the index and then populating the name into an application table that gives you an easy lookup to that face ID. So they ran that through that. The face match produced a reduction from many days to several seconds, which is obviously tremendous for them. Thousands of hours of over the course of a year of manual labor was saved. And they identified the first suspect within the first week. So this was replacing it's no more than an automation efficiency thing going on here. What they've done, they've replaced a manual search through a database of faces against a reference image, which could have come from a camera, a security camera somewhere, and then have a human run that through. So we basically just provide that as an output, and then you get a list of matches from high to wherever they cut off, but all reasonably well-scored matches, and then the detectives run with that and basically treat that as a list they can work through. Filter is a popular pattern as well. Filter is very important, and it's actually very important for human curation processes. When humans are in the loop already, you think of security, you think of content moderation, you think of a lot of these sort of situations. It's always a bottleneck simply because volume in is very hard to manage by humans, except by scaling physical people. And so filtering is a very popular pattern that we see. Inappropriate and specific content is very, very high on that list because obviously the risk of exposure to reputation and things like that from a brand by exposing inappropriate content is very high. And so this is where we see something like the image moderation providing a really neat way of just taking off the first very obvious inappropriate content so that the manual review doesn't have to. So we're saying these guys are completely safe. We're very confident with that. And then you play with those metrics, those are confidence scores until you tune it, adapt it to the application environment. So you can see the APIs there, obviously moderation labels, but DetectLabels and faces also appropriate for filtering use cases. If we think about the video example, we've seen a lot of customers doing this, and we have a small demo where we've done this as well. It's the case where indexing a series of frames, like in this case, we have a little demo that indexes 1 frame a second. We have customers doing 1 frame every 6 seconds, or in some cases, a few frames a second because they've got very dynamic content. The whole purpose of it is to build that index such that they know what's in the content at any point. And then by reconstructing it against the timeline, then you can say, here is where the text appeared in this video. Here is where Blossom appeared in this video, and so on. So that becomes a very powerful index against the timeline as well. Recognize is a powerful use case. And you'd think of that too with the name of the product as it is. The idea here is to identify specific people within a collection or collections of millions of faces. So the generic pattern here is where the collection has been built. So you index faces into that collection in preparation for the search to continue. So you can do it as a separate function and like establish a baseline, or you may want to make it a dynamic function where as new faces come in, they get indexed and then become part of the search pattern as well. So that's a good example of that would be in a social media context where you're adding faces in because I take photos, I upload them to a service. That service automatically indexes those faces into a collection such that they're now named and get named automatically. And so you can see here the general flow and the APIs that are relevant there. C-SPAN is doing this they built an index against 99,000 people who appear on their network. And so that's the building of the index took a day. Put all those 99,000 in, it took a day because they were well annotated. The whole application and pipeline was built and tested in 3 weeks. The idea here is that they're using the faces that are recognized from the input from all of their 8 networks. Every 6 seconds, they're taking an image and then reducing it by checking if it's significantly different from the previous image, and then passing the output of that into Rekognition to say, okay, who's in this image? And when they get the response, they store that in an index, and that becomes now part of the index into their video assets. So now they can say, here is a person, where did they appear on C-SPAN over the years? Or here is a video, who appeared in it? You can do both. You can answer both of those questions. Calibre is another company, an interesting company who's doing this in a VIP way, VIP use case where they're enabling hotels to identify their VIP customers the moment they walk in the door, and basically use that as an identifying mechanism to bring up all the necessary service content needed for the front desk to give that person a good experience. And rather than be looking down at the screen and typing and finding them and identifying them and bringing the stuff up, it's all there. They click, it brings up, and then they service the customer with what they call an eyes-up experience. So just shaving that 3-4 seconds from someone between the front door and the desk brings in a world of personalization and a wonderful experience for their customers. Verify is a popular use case as well, where we see identity verification against a reference face. And this is a great case where we've got a badge scan scenario. We all wear badges here at Amazon, and the example would be that if my colleague borrowed my badge or something, this would catch that, because as you walk through the gate, the badge would verify, but the badge would also have an associated image with it, which when compared with a live image taken at the time would produce a low similarity if it's not me. And therefore, that's a security violation. It would provide a validation that it is me if I'm using my own badge. So that's a really popular use case as well. And compare faces is the API where that is used. Redaction is another a popular requirement here, and really just knowing where the faces are can help you tremendously in doing a lot of things with those images. And it could be for security, public safety. It could be for privacy, prevention of non-persons of interest being exposed in sort of public settings and things like that. So we've done a rather crude example of redaction there by identifying the faces and just basically blocking them out. You could do that more elegantly with pixelation or with blurring and that sort of those sort of utilities, very easy to apply. What we're providing there with you see the detect faces and detect moderation labels, the ability to identify offending or identify areas with a bounding box in the image, such that then you can go and edit against that and anonymize the faces or reduce the identifying attributes of the people in the image. So that's a popular use case as well. We have many customers of Rekognition. We've had a very strong adoption. You can see some of them there that have publicly endorsed the product, and you can see different industries they're represented. Influencer marketing is a particularly interesting one, where building profiles of users by understanding when they're posting their social media pictures, what's going on there, what are the objects, scenes that are part of their social media profile. It really helps those companies match brands to those influencers, and therefore be able to give their customers, the brands, a better experience by matching them to appropriate influencers. So when someone is influencing a product, it's a product that they would use, it's a good match, they would post about it happily, and everyone has a good experience there. So if we just roll forward. The Rekognition console, if you haven't seen it already, we've pushed a lot of these capabilities into a console so you can use it at any time. The object, you can see there that I've enlarged the demos menu there, object and scene detection, image moderation, facial analysis and comparison. So all of those capabilities are available in the console. If you just go to the Rekognition home within the AWS console, you can upload your own images and see the sort of outputs that come from that. Of course, then, we would direct you to the AI blog. If you're not aware of that, certainly just look that up. It's part of the Amazon blog series, in which we provide a lot of good advice, but some of that being around how would you do this at batch, for example, and do tremendous volume through Rekognition by simply employing some of the tools around S3 and specifically AWS batch. So that's a great approach to picking up more information and getting started. So that's all I have this morning. So I appreciate everyone's time. We are going to jump to some questions now. We'll take a brief pause while we compile our list of questions, and we'll be back shortly.